To talk about the same, in the topic Scaling Custom LLMs on EKS, Trainium and Inferentia2-Powered AI Infrastructure, we have two amazing speakers, Adit Modi and Veera Solaiyappan. Both of them asked me not to give a big intro about them, but I'll just give a small insight. Adit Modi is a solution architect from Lauren, and Veera Solaiyappan is a senior software engineer from TEKsystems. Let me invite them both to the stage.
Okay, perfect. Cool. So, hi everyone. I hope. Thank you. First, I would like to thank everyone for coming to this session, and thank you to AWS User Group Kochi for inviting us to speak. So, my name is Adit. I work as a solution architect at Lauren. I'm also part of the AWS Community Builders program. I'm a container in the container category, as well as I'm a AWS user group leader from Vadodara, Gujarat. I'm a 12x certified, so I've got all the 12 AWS certifications, the golden jacket holder. With me is my co-speaker, Veera. Veera, if you can introduce yourself.
Yeah, hi everyone. So to introduce me in a very short manner, like I'm a senior software engineer working in TEKsystems. So I have a 6+ years of experience in various domains, which is GIS, supply chain, logistics, and a fintech platform as well. So I'm a AWS community builder in serverless category also. Yeah, that's it.
Yeah, thank you, Veera.
Yeah.
You have a... Okay. I'll just say next, okay? Cool. Next.
The remote.
Okay. So okay. Before we even jump into the agenda, right? I just want to try and quickly talk about the business challenge, right? Or why this session is important, right? So whenever you're trying to build a AI application or an AI system at scale, you will first start with any public APIs, your ChatGPTs or your Cloud, right? Any of those APIs you will use, and then you'll try and integrate it, right? And once you try and integrate it, you will soon realize in like a 6-month or a 12-month window that your bills have skyrocketed, right? Your costs are really high. You are facing issues with managing things, right? And then that's when you will think about, right? Your FinOps teams will try and ask you, why are we using this? Why is this charging this much, right? And that's when you realize that we need to build this system our own, right? We have to try and build it from scratch, something that we have to internally do. So that is the whole point of the conversation here. We're going to be walking you through the entire system and how do you build such a thing and why is it needed, right? So the agenda is going to be about in 30-35 minutes we'll take, right? We'll first, it's divided into 6 sections, right? So the first, consider each section as a puzzle or a piece, right? So everything combined together will give you the whole picture, right? So the first section here is the challenge, right? So just want to mention why do you look at this problem, right? So more from a, don't look at from a technical problem is there, right? But then look at from a business problem as well, right? Why are the costs so much? Why does it cost so much when you try and build your or use a public APIs, right? And that is the problem statement that you should look at, right? So that is like the first challenge or the problem, right? Next. Yeah. So the architecture itself is so here what we are trying to showcase is okay, we understand that there is a challenge or a problem, but then what is AWS doing in that space, right? What is the AWS role here, right? That's the first piece. After that, we understand what are the purpose-built chips that AWS has and how they help with this particular problem, right? That is the second piece. The third piece to it is, okay, we understood AWS is doing something, then how does all of this combine together, right? How does Kubernetes come into play? How does Trainium or Inferentia come into place? And how does the whole comprehensive architecture look like, right? That is the second piece. Next. Yeah, so the third component here is training at scale, right? So when we try and build, when we try and explain the problem, then the architecture, then we come on to the third piece, which is like, how do we train these models, massive models at scale, right? And how do you make this training reduce the time it takes to train, right? It takes months. You can reduce it to weeks. That is the second, the third challenge here, right? And then the next piece here would be inferencing and serving, right? So here what we are trying to cover is you need to call this model each time, right? Each time a user enters a question, there is an answer that comes, right? That is called your inferencing or serving, right? So that is that also needs to happen with minimal latency, with good throughput, right? So that is the fourth piece here. And then the fifth one is something that my co-speaker Veera is going to cover here, which is he's going to talk about hands-on the actual code that we have written down, and then how it works end to end with different components, and then he will also show a demo of sorts of how it is working, right? And then he'll also, if time permits, explain you the different cost comparisons that are taken into consideration, right? Okay, cool. I will take it. Yeah, thank you. Okay, cool. So in the end, we'll have time for questions, and we'll ask you anything that. Okay, cool. So the challenge, right? Now, I just want to focus on why, while you are, like, just let's say from the problem statement, look at it from a, you are running a company, right? Something like Uber, Netflix, Airbnb, right? Think of a scale where there are millions of users, right? Now, if the user base is very large, right? You are, obviously, you're looking at integrating an AI into your product, right? Maybe it is recommendation, maybe it is personalization, maybe it is search, right? So you start building, right? The first step that you take is, okay, let's say just start with OpenAI's APIs. ChatGPT is really good. I'll just use it. It's easy to integrate. It is fast. So I start with it, right? And my developers like the way it is working. My users increases, right? But then in certain time, right? So let's say maybe in a 2 to 3 month period, the user base increases, right? They skyrocket, and then there is a time when it comes that, okay, a lot of people are using my application, which is using AI instead, right? So let's just try and understand the scale, right? So it moves from 1,000 users to maybe 10,000 to maybe 1 million, 10 million, right? That is the scale that this user base increases to, right? Now if it increases to this particular scale, the important challenge that we find is each user is using or calling this APIs multiple times a day, right? That is fair to assume. So if that is the case, then probably you are, let's say that there is a $0.001 per request that this public API uses. It's again cheaper than, it's going to be expensive than what I'm saying, but again, just for the reference perspective, we'll say it's 0.001, right? So if that is the case, 10 million users, 0.001, roughly about $10,000 per month, per day is the cost of this API calling. And that is just the public API, by the way, right? So then after this public API, you're using this $10,000, then probably monthly it is like a $3,000, and then yearly it is like a 3.6 million. So this is again the cost that comes up if this users and the scale is achieved, right? So at this level of scale, right, you are thinking that this is too expensive for me, right? My own margin is maybe something lesser, right? So each API request that the customer hits, I'm actually losing money, right? So that is where you are thinking, okay, this is probably not a good situation to be in. And then this is like the problem that we have, right? Now, to solve this problem, right, what are the different approaches you have, right? One approach is, of course, you have the public API-based approach, right? And then another approach that you can look at is maybe custom building my large language model or platform internally, right? That is, so just to understand, there has to be a point where you decide that for me, the public API-based approach is not going to work out, and I need to now look at custom large language model building and deploying, maybe training and inferencing on my own on a control plane or something. So that is this user base. So just given you a diagram and overall look and feel of where is that point that you have to make that choice or decision of moving from a public API to kind of a other approach, which is the custom one, right? Okay, so we understood the challenge at large, right? Now let's just look at the architecture here, right? Before we dive into the architecture, I'll just try and give you a overall. I think Apar in his slides covered this briefly, right? So how many of you use Bedrock or maybe any of the Q business, developer, Hero, all of us, right? I think most of us, yeah, raise of hands, please. How many? Yeah, a lot of people, right? Cool. So, let's just try and divide this into 3 components here, right? So first component is applications to boost productivity, right? So here, what we are thinking is any application, if I want to, make it straightforward, simple, not a lot of complexity I need, right? So then I can use something like a Q developer, Hero, Q business, Quick Suite, right? So all of these tools, what they're doing is they're helping you make your applications easier, right? Easier to manage, easier to scale, things like that, right? So again, it is abstracting and the whole functionality for you, right? So that is the first layer. The second layer is the models and tools to build your GenAI applications, right? So think of them like agents, multi-agent. Again, here you're doing what you're doing is you have an LLM. You're just using a public API of an LLM, right? So Bedrock again gives you the public API, right? It has other features like Agent Core, Bedrock Agents, Bedrock Flow. So that are the second piece, right? And then the third piece is the infrastructure to build and train AI models, right? So here there are 2 different segments, right? The first segment is SageMaker. SageMaker is like the managed infrastructure, right? So here the idea is you use SageMaker when you want that functionality or the flexibility of AWS managing the infrastructure for you, right? So that's when SageMaker comes in. And our focus today is on the second piece, which is the Trainium and the Inferentia GPUs, right? So here the idea is how do I use the infrastructure from AWS itself to build and train my AI models, right? So that is what we are trying to focus on. I know it is not a very interesting topic. It's kind of a boring topic, but from my experience, it is a topic which is very underrated. AWS has been doing a lot of innovations in Inferentia, Trainium GPU workloads, right? So a lot of interesting stuff has been coming out, and I hope to see a lot of people show interest here, right? Okay, so as I said in the agenda, right? We'll first, in the architecture, we'll give you an overview of what are the different components, where does the AWS is AI and ML or infrastructure piece come in. We discussed that that is the Trainium and the Inferentia. Now let's just look at from a AWS overall, what is it doing in this AWS infrastructure space, right? What is AWS doing, right? So there are 3 things here, right? So a lot of people think that AWS is not really innovating. They're not creating silicon chips and all, right? They recently started doing it, right? But I'm just going to break the myth. You're thinking wrong. AWS has been doing silicon chips from a long time. So whenever you run an EC2 instance, underneath you are running a Nitro system, which is a hypervisor plus a chip that is built by AWS itself. And it is not your normal NVIDIA, Intel, AMD chips. It's custom AWS built, right? So that is where I'm the first piece, right, which is the the Nitro system, right? The second one is something that AWS announced or launched, which is the Graviton. Now Graviton, how it works is it's basically giving you the additional functionality, right, which is more better performance, better CPU utilization compared to your Intel and AMD chips, right, at the same cost or a lesser cost, right? So that's where the Graviton, again, it's an AWS its own chipset, right? And then the third piece here is the Trainium and the Inferentia, right? Now, Trainium and Inferentia is something called purpose-built chips, right? Now, what is purpose-built chips, right? The idea of purpose-built chips is that they are going to solve a specific purpose, right? When you have GPUs are mostly people use GPUs for everything, which is any high computing workload, any machine learning AI workload, I'll use my these GPUs, right? But then you should also think about using Trainium and Inferentia, because Trainium and Inferentia are purpose-built for a specific purpose, right? So for Trainium, the purpose is training, right? It's sort of just designed to help you train your models, right? And then the second one is Inferentia. So Inferentia, the purpose or the idea is going to only do inferencing or serving the model, right? So that is why it is called purpose built, because the idea is you are only doing or only solving a particular purpose or particular problem statement, right? Trainium, training. Inferentia, inferencing, right? You're solving a particular problem. That is where they are different from all of your normal GPUs, NVIDIA GPUs that you hear about, okay? So next, I want to just focus on Trainium itself, then Inferentia, and then Inferentia 2, right? So for Trainium, the idea is, as I said, it's doing training, right? So distributed training is something that it does. Under the hood, this is the chips that are being used for doing training, right? Now, the important thing is it is 30 to 40% cheaper than your normal GPUs, right? That is the sort of advantage you have because it is the underlying architecture that Trainium follows. We'll dive into the architecture when we're doing the training base. But that is why it is cheaper compared to your normal GPUs. When you run it on a single GPU, it is like 8x faster, right, compared to your normal GPU. So that's how efficient Trainium is when you do model training, right? The next piece here is Inferentia. So with Inferentia, the first one is just for running your deep learning models, right? So if you are inferencing your deep learning models, this is the chip that you need to use. And then Inferentia 2 is something that you use when you are trying to inference or serve your GenAI or LLM models, right? So that is something that have to be used there. Okay, so we understood AWS overall architecture. We understood the different purpose-built chips that are being used. The next bit to understand is the Neuron SDK, right? Now, what is Neuron SDK, right? A very simple, basic question, right? So let's just first understand the couple of layers. Once you understand those layers, you'll try and understand what Neuron SDK is, right? So first thing is the AWS Trainium and Inferentia, right? So that is your purpose-built chips. We understood that, right? Fairly straightforward. The second one is the Neuron SDK, right? Now, think of Neuron SDK as something that your models, so if you have like a Hugging Face or a Ray, right? These guys will give you some models, right? And then that has to be converted to something that the chips understand, right? Something that has to happen. So Neuron has a software on SDK which converts the language of the models to something that chips understand so that these chips can compute or do some computational work, right? So that is fairly straightforward. Neuron SDK understands things and then puts it into these chips, right? Now, above the Neuron SDK is the AWS Cloud Services, right? We already are aware about those things, right? SageMaker, ECS, EKS, right? And then there's something called Neuron Containers and Neuron AMIs, right? Now, each application or each something that needs to use your Trainium or Inferentia should have a Neuron container or an AMI internally inside it, right? So that when you are trying to build, train, or inference something, you are trying to interact with this, and then internally it is interacting or using your Trainium and Inferentia. That is how it will work, okay? And then the fourth layer about the cloud services is your third-party software. Now, these are softwares that you use to train models or to inference models, right? For example, you use something like a Ray for training, or PyTorch is a good example of something you are using for training, right? And then for inferencing also, Hugging Face also has a trainer. And then for inferencing, you use something like a Ray Serve or maybe something like a VLLM, right? It's very common nowadays. And then there are other things that you use for orchestration. So something like a Datadog, something like a Kubernetes for orchestration. Fair? Is this slide clear, right? Yeah? Cool. So, so this is all the entirety of layers: Trainium and Inferentia, Neuron SDK, cloud services, and third-party software. Okay, so this is the a very simple and a basic architecture, right? So here you see Kubernetes being the orchestrator, inside it being your training jobs, your serving jobs. Here, just for reference purposes, we have both TensorRT for training and then VLLMs for serving, right? And then internally, the hardware that is being used is the Inferentia and the Trainium, okay? And here I want to focus on something called like why Kubernetes, right? Essentially, it's important to understand why we look at Kubernetes for these particular jobs, right? So the idea here again is Kubernetes does something where you need Trainium hardware. I'll just spin up a Trainium node, right? If you need inferencing, I'll just spin up a Inferentia node, right? It doesn't, it just, for example, if it's a CPU or anything simpler, right? So it will also do it same way, right? So it doesn't distinguish or it doesn't differentiate Trainium and Inferentia, right? So that is an easier thing to do because if I want to scale something up, I can just tell Kubernetes to create more node groups, it will do it. If I need to scale down, it will also do it, right? So the inbuilt functionality of Kubernetes, which is the auto-scaling components, the flexibility of increasing, decreasing the capacity is where it will be really helpful to use it, right? So this, again, is an architecture of the different components that form your this entire piece of training and inferencing serving, right? So here you look at ML flows, right? So here, something like a PyTorch, something like a TensorFlow, right? So these are all for your training or building and training your models. Then comes a container registry for storing your models. Then comes model registry for versioning and keeping the track of your model versions, right? Then model experimentation, something like a Jupyter Hub, right? You use it just to brainstorm ideas or try and see which one works, which one doesn't work, right? Kind of like that. And then you come to the model training part. This is the one where Trainium is efficient, right? Which is Kubeflow, Ray, Hugging Face can be used. Training, evaluating, validating, right? Then you come to the inferencing serving part, where you can use Ray serve VLLMs or Hugging Face, right? Again, you're doing model deployment and then model serving, right? Internally, all of this uses S3 or FSX, your internal neurons, right? Which is like Trainium 1 or Inferentia 2. And also, they can use your SageMaker for a managed infrastructure. Okay? Fair? Cool? Yeah? Okay, training at scale, right? Now, this is the piece, why training at scale is a problem, right? Let's just understand why Trainium is needed, right? For example, right? So if you want to train a model, right? The idea is you'll probably maybe take a 10 billion parameter model, right? It will not fit into one GPU. The memory is not enough. That's the first problem you run into. Takes forever to train, right? It takes a lot of time for you to train this particular model, right? Then it's like a longer duration, lot of cost. One alternative is called data parallelization. That's something where you are distributing your data into different node groups or different GPUs, right? So then you are having one model, you're keeping the copy of model in one GPU, another one, right? And then you're asking them to batch process. So you're saying you process one bit, you process another, and then all of them have to be synced up, and then again you have to do the process. The problem here is the syncing up is where it takes time, because one GPU is slower, maybe one is faster, right? It lets all of them finish together, and then it syncs, right? So that is where the bottleneck is, right? The data parallelization is a good technique, but the bottleneck is the synchronization, where it needs to wait for the slowest GPU to compute, okay? So that is where we are at. Now, with Trainium, right, why is it a good solution, right? Multiple chips work together, process is in parallel, it takes lesser time, cheaper, right? Now, let's just see how it is cheaper, right? So here, if you look at this example, right, what it is doing is it's splitting it, right? Which means it's first thing it is doing is it's splitting the model into different chips. But the way it is doing it is it's dividing it into 25%. It's not putting all the model inside that one chip, right? So the percentage value wise it is putting the model. It is then batch processing it. And then once it is done, then it uses something called a neuron link to connect or to send the data back to another chip, because you need to sync everything, right? So that is the advantage here. That is the speed it does it with. So split models across 4 chips instead of 1. You're splitting it. Second, all chips work at once, so there is no waiting, right? And then ultra fast chip connections. So this is what I was talking about, the neuron link, right? Okay, so we understood the training bit, which is why there is a problem in training. Why does Trainium help with training? Next is inferencing and serving. So here the idea is, first let's just understand, like training is something that happens once you want to update the model, right? So it's not going to happen every time, right? You're just going to be training it once every now and then. With inferencing, you are doing it all the time, because when I ask a question, I want an answer, right? So inferencing is happening continuously, right? So that is the difference between a training versus the inferencing, right? Now with inferencing, the idea is you want to have the least latency, right? Because when I ask a question, I want it to not take a whole lot of a second or maybe 2 seconds, right? It should be very fast when it does this, right? So how does something like a Inferentia help you with this, right? Because in a normal GPU, the latency is higher. So, and again, it feels very slow. And then there is expensive at scale. So with Inferentia 2, it feels faster because it has a lot of lesser latency, right? And it is cheaper, right? So it's cheaper than your normal GPUs. It's 70% cheaper than your normal GPUs, right? Cool. So, correct. Now, so we have discussed, till now what we have discussed the challenge, the architecture that is in place, the training, and then the inferencing. Now I'll hand it over to Veera. He's going to talk about the actual code that he has deployed and how does it look, and then the cost bits. Okay, over to you, Veera.
So, okay, I hope now you got the basic context about what is Trainium and then what Inferentia 2 it's exactly it's doing it. So the basic, like why we need the session is like the basic, the question for the session is why we need our own custom LLM platform. Since already there are some other third-party providers also they are providing it, the OpenAI and then the cloud also they are providing it. Then instead of then why we need our own custom platform is, so there are three major components. First is cost, second one is control, and third one is compliance. The cost wise, for example, if you are using OpenAI model, it's a GPT-4 if you are using it. If, for example, if you are getting a 1 million token inference every month if you are getting it, we will easily get the cost of $60K, we will get it. If you are calculating for the years, definitely it will go around $720K, you will get that. It will be really huge. And then the control wise, so we don't have any control about what third party is doing it. So for example, they can easily increase the price wise, they can increase that. And then rate limiting also, they can increase that. And then they can easily deprecate any models also, they can deprecate they want. So I hope you remember about the OpenAI, they deprecate the GPT-3 model, they deprecated. And then another one, criteria is like compliance. So for example, many of them, we are mostly working with some of the healthcare products or banking system, and some of the government projects also we will work that. In that situations, so it will not be good to allow our data to send to some other third-party system. So that's also the major things. So that is the reason we need to build our own LLM platform for our organization, the development and usages. So I will focus on the technical difficulties and technical details, what are the code level changes we have to do it, and how exactly it will look like that. So if we have a time, then we will discuss about cost comparison also, we will discuss about the various service providers and various systems we have. So, okay, this is the overall architecture. We created the demo with using very tiny model, the model called Tiny LLM. Okay, it's having 1.1 billion tokens it has. So we deployed into the EKS. This is how it will look like that. So we can see three different nodes. So first one, T3 node, that we already familiar with the EC2, the basic node we can say. And second node we can see that is a Trainium node. That's specifically for training our LLM models. And third node we can see it for Inferentia 2. So that specifically for serving our LLM to as a API server to our users or developers we can use it. So in system node we can all our non-LLM jobs whatever we have, whatever non-LLM ML jobs we have, everything we can add it here like core DNS and load balancer control and the neuron device plugin. The neuron device plugin I will come to later part. So whatever non-ML jobs we have, that everything we can add it in the normal EC2 system nodes we can add it. And whatever the training related jobs, everything we can add it into the like a Trainium node. And then the Inferentia node also for serving the APIs. So and then basically what the Trainium node it will do, it will download the model from Hugging Face or any other open LLM service provider, any LLM model provider, and then it will download and then it will train the model with our own data sets if need that. For example, in the Trainium model, we can do our pre-training or fine-tuning also we can do that. And then it will we can save the model into the EFS, it's a file storage, elastic file storage, we can save that. And then we can provide the same, some mount point we can provide that. Using that mount point, we can share the specific place where the model is saving. We can share it with our Inferentia. So Inferentia also download the latest fine-tuned model and then it will serve the API. So and then for backup we can use S3, and then like a CloudWatch that we can use it for monitoring, and observability we can use it, and then we can use it API like a load balancer for like API serving. We can do that. So I hope you understand about the architecture, I guess. So now next, okay, so how exactly it will look like in the code level. So now we know about like a Trainium and Inferentia, and then like how it exactly it looks. So when code level, what we have to do, how many of you familiar with Kubernetes configuration? I hope some of them are already familiar with that. So here, I hope this is where we have to define our pod configuration, right? So in the resources, we have to set our how many CPU we need, memory we need. For example, if you are running any training jobs, it need a neuron. So this is where we have to mention aws.amazon.com/neuron. So it will make sure, so the particular pod, it will only run in, like the Trainium nodes, it will use that. The neuron node, it will run that. So next. So okay, so now I have I set it my configuration to run the specific pod to specific neuron node. So and then in Kubernetes also it will do. For example, if any of the node is available, it will allocate the pod to the specific node. That's that kind of problem also Kubernetes it will do that. So to avoid that, we have to set the node affinity. We have to set it. Node affinity means we have to restrict it for only the ML related or LLM jobs only will be run into the Trainium. And then inference things, everything, it will be run into the inference server. Those kind of like node affinity we have to set it. So this is how we have to do it. So the first level of the code, we can see it in the Terraform, and second layer, we can set it in the Kubernetes configuration, we can do that. And then this is for like a model training. So there are three components it has. First one model, and second one tokenizer, and third one optimizer, and fourth one like the training the model. This is how the code it will look like for training the model. So in between, this is the kind of basic code level. So we can add our own fine-tuning code also. We can write it down, and pre-training code also, and dataset load also we can set it here. Okay, this is the like a code for a basic code for inferencing the model which we pre-trained or like a fine-tune. So here we can see the model and the tokenizer, we can see it. And then I'm using fast API. So fast API, through the fast API, I can serve my LLM to as a API server, I can do that. So I'm loading the model, and then next I'm creating the tokenizer, and I'm creating the API for that. Okay. So next, okay, this is for another one, optimization level. So for example, in cost wise, it's one of the huge things. So for most of the training jobs, it only takes certain hours only, 4 hours, 6 hours only it will take that. So in that case, we don't want to use any on-demand instance. We don't want to do that. So we can go with some Spot instance, we can do that. So for example, in the Spot instance, I can get it. I can only run for 4 hours. Then I can close my Spot instance. So then whenever it's needed, the Kubernetes, it will take the instance back. So it will if you are using on-demand instance, it will cost $1.3 per hour. If you are using Spot instance, it will just cost 40 cents per hour. So that is a 70% of savings we can get it. And then the Neuron device plugin, it's actually what it will do. We already, Adit already told about Neuron SDK. So Neuron SDK, what it will do, it will tell your system, this is your Trainium chips, so use it. So that adapter, it will do it. But in Kubernetes, that is a different environment. So in Kubernetes, we have to clearly tell them, so this specific node is using Trainium, this specific node is using Inferentia. So we need to use Neuron device plugin, we have to use it. This Neuron device plugin, we have to use it as a daemon set. So whenever there is a new node is created, it will attach that, and then it will tell Kubernetes to, this is the Neuron node, this is the Inferentia node, that it will tell that. So okay, so yeah, this is the demo. So we'll play the video if you have time.
The video.
Yeah. So what we did that, we created the script. In that script, it will run the entire infrastructure. Like we write our Terraform script, everything run. We created that. That will run all our EKS cluster, and then the node, everything, the node group, everything, it will set that. And then once that job is done, then it will download the model. It will run the next Kubernetes configuration, Kubernetes pod, everything, it will start to deploy it. So, and then it will start downloading the model from the Hugging Face, and then once the training job is done, then it will Inferentia model, it will take the latest fine-tuned model from the EFS, and then it will provide the API interfaces. Through that, we can hit that API, and then we can do the chatting. We can do that. So now we can see the deployment is done. So okay, so now deployment is done, and then the system is also running. So yeah, I think next we will do. So why we are running the demo is a video recorded is hardly it will take to execute it 25 to 35 minutes due to the time constraints. So that is the reason we recorded our session. So we are providing. The video is playing, yeah. Okay, the system is healthy now, and then okay, so this is how generally once we get the API, we can ask our own questions that we can do it. So yeah, fine. Next, move to the pause the video.
Yeah, pause and we can move.
Okay, so how we have to calculate our resources. Resources means, for example, I want to deploy any other models in my system. So how I have to calculate my CPUs and memories, how I have to calculate that. So there is a calculation we have. So for example, for an inference, let's talk about first training, let's talk about that. So the equation is memory equal to parameters. The parameters are, for example, I'm having a 1 billion token model. So that is the parameter, 1 billion token. And then and then the bytes it takes for each params. And then into 4. The 4 calculation is for a model and Gaussian and optimizer. So this is how we have to calculate for the memory for training model. So for example, the Mistral 7B model, if BF16 is the kind of the precision they are calling it. So that's for bytes per param. So for example, 7 billion model into 2 bytes into 4, it will take 56 GP. So for example, to run the Mistral 7B model, it will take 56 GP. We have to allocate for our training job. And then the same for inference as well. Inference, rather than using into 4, we have to use 1.2. We have to multiply with 1.2. So the same, it will take 16.8 GP. We have to allocate for running Mistral 7B. The next, this is it's related with the previous slide. So we talked about bytes per param, right? So how it will look like. So generally, what is the precision is how we have to find the specific model, how we have to find the high accuracy model, how we have to find out that. Using this precision only, we have to find out that. The precision, it will give high accuracy. If precision is what precision is, it's a model weight, it will provide that, and then accuracy also it will provide that. For example, if the model have FP32, it will provide high accuracy. Okay. Then based on that, we have to calculate our bytes, and then the storage, everything we have to calculate that. So yeah, this is how we have to calculate our the model, the memory we have to calculate it. And next, the size. This is also okay, so now I got my size. How I can allocate my instance, I have to allocate. Based on the model size, I have to choose my neuron cores, how it, for 8 to 12 GP, I need a 2 neuron core, and 14 to 20 GP, I need a 2, and 140 to 80 GP, 180 GP, I need a 24 neuron cores, and this is the instance type I have to choose it. Yeah, so cost comparison wise, so these are the various service provider. So for 1 billion tokens, how much they are costing for monthly, okay. So OpenAI, ChatGPT-4, they are costing for a 1K inference, $60, okay. And for example, if you are using EKS plus Inferentia2 spot instance we are using, we can see the difference, $0.17. So that is the difference actually, okay. So next for training also the same. Like for example, if I am using SageMaker, GPU SageMaker, if I am using it, so for 10 hours training, I will get the cost around $327. I will get it. If I'm using EKS with the Trainium, Spot instance I am using it, I will get the $4 cost. I will get that. So that is the like the difference of the services cost. Yeah, the key takeaways. Okay, so the key takeaways for the session is 50% of the lower cost we can get it when we are using EKS, Inferentia, and Trainium, even on Spot instance if you are using it. And then 40% of the lower inference cost also we will get it. And then the latency also is very low. Inferentia 2 is specifically for low latency. So we will get 100 millisecond response we can get it. And then it is a kind of unified EKS operations. So everything you can manage it in the EKS. We can manage. Yeah, I think, yeah, so this is your next step. You can scan the last QR code. You will get the live demo repository. You will get that. So you can go and play around with that. Yeah.
And I think the first and the second ones are also important. So the Trainium and the Inferentia docs are in the first one, the ones that I was talking about. And then the second one is more about the whole deployment, how VLLM and EKS deployment works, right? So yeah, just scan those and take a look at those.
Done? Okay. Thank you.
Yeah, any questions if you have for us?
Let's make it quick. It's lunch time.